welcome to Lesson 8.6b. This is the follow-up to Lesson 8.6a, obviously. This is Miss Fleming. And in 8.6a, you had an exercise or an activity where you had to do a water balloon contest. This doesn't relate to that at all. This is actually an applications, solving applications using the zero product property or by graphing lesson, but it stands alone. All right, so let's review a couple of things. First of all, and gotta get her the pen on. Okay. Yeah, it's me, the one who doesn't write very well. All right. We're going to do word problems, and the word problems today are all rectangles. So we are going to be doing area is equal to length times the width. And as a review, this is Algebra 1. So we are only finding real solutions, and those are otherwise known as the roots or the zeros. When you see solve the quadratic or find the roots or zeros, it is looking for one thing and one thing only. It wants you to find the x-intercepts, and you really need to get that fixed in your brain. You are looking for x-intercepts, and in most cases, there are going to be two of them. Oh, and I actually had that there after I about to write that down. So we can use any method we want. Right now we know two methods to find the x-intercepts. We know how to do it by graphing them with the calculator and using 5-intercept in the calc function, or we can factor them, set each factor to 0, and solve for x. That is known as the zero product property. All right, now I want you to remember this because this is going to reinforce something about how the calculator works. I have standard form, y is equal to ax squared plus bx plus c. If I am looking for x-intercepts, all of them have a y value of 0. So this y is the same thing as this 0. This is factored form where a is a GCF, and here are the factors. And again, I am looking for x-intercepts. Every y in an x-intercept is a 0. So this means the same thing as a y. And this is vertex form. Exact same speech. All right, anything that has been solved for y can be graphed. Big point. All right, here's my first example. There are 3 examples. It's a pretty short lesson, pretty painless. So let's go ahead and get rid of this. And example 1. They're all rectangles. Some of them are more interesting than others, but so be it. The floor of a rectangular room has a length that is 4 feet more than twice its width. If the total area of the floor is 240 square feet, then find the dimensions of the floor. Okay, let's break down the words. First of all, dimensions is a fancy word that means length times width, or length and width. If this was a cube instead of a rectangle, we would have length, width, and height. So you can have 1 dimension, 2 dimensions, or 3 dimensions. Okay, area is length times width. So right now I know that the area of this floor is 240 square feet. So my units are going to be in square feet. And now let's go back and see where we came up with these numbers. The rectangular room has a length that is 4 feet more than twice the width. All right, when you define variables, the one that you know absolutely nothing about, in this case width, is the one that's going to stand alone. I could use an x here. We have to use w for width. So the other variable, which is a length, I'm not going to state that in terms of L. I'm going to say, what do I know about that variable? Well, I know that if I had the width, I could, 4 feet more would be plus 4, and this means, let's put a plus 4 above that. Okay, so this would be 4 feet more would be plus 4, and twice the width is 2 times the width. So how did we come up with, no, I don't want that one, I want this one. How did we come up with the length being 2x plus 4? Right out of that sentence right there. So one more time, and this part is going to trip you up today. So let's get it nailed down right now. The length is going to be stated in terms of the width, because the width we don't know anything about. We know 0 about the width. But we know the length is 4 feet more than 2 times the width. And that's where we got that statement. So now that I know a statement or an expression for the length, an expression for the width, I can fill in my area. Okay, so area we got right here was 240 square feet. And I use a commutative property to switch the width and the length around because I like to put the W here in the front or anything that's by itself up here in the front. So that's why I said that. You don't have to use a commutative property if you don't need it. And if you wanted to write this like this, where I kept length times width, I would have written 2W plus 4 and put the W on the end. So you can do that if you want, and then you distribute this way. All right, so the next thing I'm going to do is a distributive property. W times 2W is 2W squared. W times 4 is 4W. I am very nearly there. You can see where things are coming together. This is my x squared term. This is my x term. And I've got to do something with this. And all I've got to do is subtract it from both sides so that I have everything on the same side. If you remember, that was a rule in lesson 8.3. Said before I can put anything in the calculator or do anything else with it, that's 240. Okay, those cancel out. There's my 0, and 2W squared plus 4W minus 240. All right, now, there's the 0. If at this point, well, I'm not going to get ahead of myself. I'm going to hold off on that. We're going to factor this. And if we fully factor, we're going to find a GCF. And I can divide every one of these by 2. I can't find anything bigger than that because the biggest number this has is a 2. So we divide everything here by 2. There's my GCF that was the 2. Divide that out, and I'm ended up with a W squared plus 2W minus 120. Okay, at this point, if I put my diamond together so I could factor this, I would have a 1W. This is A times C. A is an understood 1, so it's a negative 120. B is a 2. And now I need to know what can I multiply together to get a negative 120 and add together to get a positive 2. And that's going to be a 12 and a 10. And since I need this to be a positive 2, that's going to be a negative 10 and a positive 12. 12 minus 10 is going to be a positive 2. 12 times negative 10 is a negative 120. So my factors now, there's my GCF, don't throw it away. My factors are W plus 12 and W minus 10. All right, the zero product property says that if I multiply two things together and their product is 0, then one of them must be 0. So we take these out of here and separate them out and set them both equal to 0. And if I subtract 12 from both sides here, that gives me one width that could possibly be a negative 12. And if I add 10 here, then that gives me the other width could possibly be a positive 10. So here's my two possibilities. This is a physical object out in the real world. It's a real rectangle, and the width of this rectangle cannot be a negative number. I can't say the width is negative 12. That would make no sense. So this width is 10. W is 10, so the length is 2 times 10 plus 4, and that gives me a length of 24. The area was 240 square feet, so this is 10 feet by 24 feet. Pretty straightforward. Okay, we're going to do it again, but this time we're going to do it with the calculator, because you can now see what I am looking for when I'm solving this rectangle. These are x-intercepts. All right, here's my next example. And then I've got one down there with fish in the pond. All right, this rectangle. It's nothing fancy, it's just a regular rectangle. And the length is 7 feet less than 3 times the width. So again, I don't know anything about the width, so it gets to be W. And I left plenty of space here so you could draw a diagram if that helps you picture this. I like diagrams. So there's the W. And the length, which is going to be this side, is 7 feet less. So that says I'm going to subtract 7 feet. But what I'm going to subtract it from is 3 times the width. So this is 3 times the width. So the length down here is going to be 3W minus 7. Okay, that's better. My total area is 20 square feet. That's another way to write square feet, feet squared. So there's my 20 for my area. And again, I like to put width in front of length because I like to distribute this way instead of the other way. So my width is W, and here's my 3 times the width minus 7. I have to get everything on the same side, so I'm going to subtract that 20 from both sides. And those are gone. So now I have 0 is equal to W times 3W minus 7 minus 20. I could use a distributive property here, and I would get 3W squared minus 7W minus 20. But I don't need to do that. My calculator doesn't care what form this is in. My calculator is just fine that this looks like this. And remember, I'm going to look for x-intercepts, so this 0 is really a y. So I'm going to go ahead and bring up my calculator, and we're going to go through and we're going to find the x-intercepts for this thing. Okay, I'll put this off to the side so we can see it. Maybe. There it goes. All right, so what I'm putting in at y equal, and I'm going to clear this out first, is, remember I can't put a w in, so I'm going to put an x times 3x minus 7 and I'm going to subtract that 20. Okay, we're going to look for x-intercepts, and I cannot look for x-intercepts unless I have a 0 and y sub 2, because I have to give the calculator something to intersect with. That is a critical part. You got that drilled into your head, I hope, in 8.3. So let's go ahead and graph this. All right, right now, I see it starts up here somewhere. It has an x-intercept right there. It goes down here and hits the vertex, and then it's got an x-intercept right there. We just went through a rectangle. We said I can't have a negative width. So I'm not even interested in this one. The only one I'm interested in is that one. And I don't have to zoom or anything else. I can get there. I can see that just fine. So I'm going to go to second trace, option 5, and I'm going to swing around. And there's my cursor. Okay, now I'm going to press enter. It says first curve. I'm pressing. I think that the phones say bound right and bound left, something like that. Okay, there's my point of intersection. It's at 4, 0. And that's great. I can work with that. It's a positive number. It makes sense. So I'm back here. And what that tells me now is that I had 2 x-intercepts, but I only cared about the one that was positive. So I've got, actually not an x, I've got a w is equal to 4. My units are in feet, so that's 4 feet for W. And I've got to find the length and the width. So my width is equal to 4 feet. My length is equal to 3 times 4 minus 7. So what's that going to give me? Why, that's really a strange number. That gives me a length of 4 feet. Or excuse me, 5 feet. I guess it works. It does. It's longer than the width. I expect the length to be more than that, but it's 1 foot longer, so it'll work. So here's my dimensions, the length and the width. Okay, now here's my fish pond. And what I have here is a rectangular koi pond that measures 6 feet by 8 feet. So here's the pond. It's 6 feet by 8 feet. Koi are fancy Japanese goldfish, and there's one swimming right there, and there's one right there, just so you don't want to miss the fish. The total area of the pond and the walkway. So this is the walkway. The whole area of this whole outside part is 120 square feet. All I need to know is how wide the walkway is. I don't have to do anything else. So area is equal to length times width. There is 120 square feet is my area. Now we need to go see how I came up with those numbers. And this is really easy. So make sure the pen's on. It is. All right, follow this side first. This is the unknown. We don't know the width of the walkway, and that's what we're trying to find. So it's unknown. It is x, and I'm going to put that x right here. And what I need to know is this entire length and this entire width. This 8 feet, I'm going to bring it down and put it here. And I've got another x, so I'm going to put that x here. So I've got x plus 8 plus x. That gives me this length is x plus x is 2x plus 8. And that's where that number came from. Okay, over here, the length of the walkway here is still x because the length or the width of the walkway is the same all the way around. So there's an x from this x right here. There's an x from that x. And there is that piece right there, which is the 6. So the width is that x plus this 6 plus that x. X plus x is going to give me 2x plus 6. So I have a length and a width, and they're right there, length and a width. All right, so I use the distributed property to multiply this, and then I subtract 120 from both sides, and it gives me that. All right, now let's in on a little secret. Okay, so we multiply that together, 2x is 4x squared, 2x times that is 12x, 8 times that is 16x, I better write this down, 4x squared, 2x times that is 12x. That helps so you can see it. 8 times 2x is 16x. And 6 times 8 is 48. So using the distributive property or generic rectangle, that's how we got here. Combine like terms right there to get the 28x. All right, subtract 120 from both sides. And that gives me 48 minus 120 is going to give me the negative 72. All right, at this point, I could factor this. I'm pretty sure that I know at least I've got a GCF of a 2, but more than likely I've got a GCF that's a 4. Or I can solve this by graphing. And solve it by graphing means I can use my calculator. And this is the little secret. I could have actually, up here, I could have subtracted 120 from both sides. And I could have used my calculator and found 2x plus 8 times 2x plus 6 minus 120, I could have put that in the calculator just as easily. The calculator doesn't care what form the quadratic's in, it's going to work just fine. So that could go in the calculator like that. Everything had to be on the same side. Or this could go in the calculator because, again, everything had to be on the same side. We're going to be conventional. We're going to go ahead with this one. And as you can expect at this point, we expect to end up with two numbers, one positive and one negative. And the only one we care about is finding the width of that walkway, and it's going to be a positive number. It's not going to be negative. So I'm bringing up the calculator again. And let's go clear this out. I've got to have that 0 at y sub 2. And we're putting in 4x squared plus 28x minus 72. We're going to graph this. I think we're going to have to resize it. Well, technically we wouldn't have to because I can see both x-intercepts right there. And because this is positive, I know it opens up, so the vertex is down here somewhere. I'm pretty much going to go with it. I don't see any point in resizing that because all I want is that x-intercept. So I'm going to go second trace. And I know because this calculator lands on the y-intercept the first time it graphs. And that y-intercept is a negative 72. There's the y-axis. So I know that cursor's down here somewhere. So I'm just going to slide up there. And there it was. It just jumped right past. Okay, I'm not going to get much closer than that. So I'm going to go ahead and let my first curve, second curve guess go from here. So there's one. Now we're going to do the second curve, and we're going to guess. And right there is the positive x-intercept, which is a 2. So what does that tell me? That tells me that the width of my sidewalk, which is what the goal was, is to solve for x. And I got an x is equal to 2. I don't want to do it in yellow. All right, they give me an x is equal to 2. That's what I was solving for, was x. My units are feet. The area was square feet. My width of my walkway is just going to be 2 feet. And that is everything for the examples for this lesson. So you've got, coming up, you've got 6 practice problems. One of them looks like this one, which is the last one. Have fun, and I'll see you, or you'll be hearing from me. Bye.